Hello, I am Thais Damasio, and I am a master's degree student at UFMG. In the last Fernando's class, we saw how to classify the branches of the program as taken or not taken, using logistic regression. Today, we shall see another classification problem and how to solve it with the KNN algorithm. Sometimes, we want to know if two programs are similar or not. This ability to identify similar programs might help us to detect plagiarism, for instance. In the programming context, plagiarism is related to a person using someone else's source code to make a solution and claiming it as their own without giving proper credits. But when is a program similar to another program? There are many ways to evaluate similarity, and machine learning is one of them. If you want to know if a program is similar to another one, we need to define which program representation we are going to use and what characteristics of that representation are going to be used in our analysis. We have seen the histogram representation and we shall use it in our class. Our goal in this video is to show an example where we are going to assign the same class to programs that solve the same problem. For instance, if two programs A and B aim to calculate the distance between 2 points, they must belong to the same class. But if A calculates the distance between 2 points and a third program C is responsible for translating a text that it receives as input, then A and C do not belong to the same class. Let's use a set of programs available at this link to work in an example. This data comes from a set of benchmarks called POJ104, which was first released by Lily Mo in a paper from 2016. POJ contains thousands of programs taken from an online program judge, so some programs solve the same problem. That's a good dataset to see if we can identify programs with similar purposes. Here, in this table, we can see a sample of this set. Each row in this table is related to a program histogram with only two features. The first feature is the number of instructions that implement comparisons in the LLVM intermediate representation of the program. The second feature is the number of branch instructions in the program. The BR instruction is responsible for jumping to a specific branch based on a condition. The last column represents the program class. Mind it that this example is rather synthetic. It does not really reflect the characteristics of real-world programs. Just as an example, imagine that I have a program like this one. We can produce the bytecodes for this program using Clang with these arguments in the command line. To get the number of comparisons and branches, I will first invoke mem2reg on the program. Mem2reg will clean off some of the stores, loads, and allocas, making the program easier to read. Now, let's take a look into the CFG of this program to count the number of branches and comparisons. I know, fonts look small, but you can believe me when I tell you, for instance, that we have two comparison opcodes in this program and 6 branches. Every basic block ends with a branch, except the last block in this example, that ends with a return instruction. Anyway, let's get back into the program representation. We can think there is a universe of programs, where each program is represented by a point, and the coordinates of this point are represented by the dimensions of the histogram. Our dataset has programs represented by a histogram with 2 dimensions, and we can plot these programs using a 2D chart. Each point represents a program. Programs with the same class have the same color. If we receive a new program C of an unknown class, how could you classify this new program? What is the class of C? Since we are talking about machine learning, we could use an algorithm called KNN. KNN is an acronym for k nearest neighbors. This algorithm is a supervised learning method developed by Evelyn Fix and Joseph Hodges in 1951. K, in this case, is the number of neighbors that we are going to consider when trying to classify a program. Now, let C be the new program we want to classify. So, we want to find a class for it. We start by calculating the Euclidean distance between C and all the programs in our dataset. Next, we sort the distance in descending order. The k nearest neighbors are the k first programs in our sorted distance list. The class of C will be the class with the highest frequency among the k neighbors. Now, let's go back to our initial example. In this case, suppose that C is represented by this point. We need to calculate the Euclidean distances between C and each program point in our dataset. For example, the distance between C and this point at 9:34 can be calculated using their coordinates. We are talking about a geometric interpretation of distance in a 2D space. We use the formula of Pythagoras to compute this distance. We just need to plug the coordinates of the points in the formula. And for this particular pair of points, we get 14.14. Let's do this for all the points and we will get this list with the distance. Let's sort this list. K is the number of nearest neighbors that we will consider in our analysis. Let's set k equal to 5. So, we need to get the first 5 points in our sorted list. Here they are, the 5 points of interest. Note that class 1 is more frequent among our k neighbors. Therefore, C will be classified as a program of class 1. As a final note, Evelyn Fix and Joseph Hodges were the minds behind the KNN algorithm. They worked at the University of California, Berkeley. She was a mathematician and statistician, and he was a fellow of her who also worked with statistics. They passed away but made great contributions to science. Thank you for your attention and feel free to make questions.